In this video, we want to determine the absolute extrema for the following function and interval. So shout out to tutor.lamar.education for this problem. All right, let's work it out. So absolute extrema, what we're trying to do is find the absolute maximum, absolute max, and absolute min. And to do this, we need to check a few things. First, we need to check where the derivative is equal to 0. So check the points. So check t values for when g prime of t is equal to 0. So those are the t values we need to check. Also, check endpoints. We need to check endpoints. And the reason why we check endpoints is because the derivative at endpoints of a graph are not defined. So for example, if I have some graph that looks something like this, notice how in this case the minimum value is here, so this value will be determined from taking the derivative and setting it equal to 0, but the maximum value is actually here, right? And this is minimum, and this value will be determined by checking one of the endpoints. And the reason why the derivative won't give us any information on this point is because the tangent line at this point, there's no such thing, right? Because I can draw a tangent like that, I can draw a tangent line like that, and many other directions, right? So the tangent line slope at this point, it does not exist. So for that reason, we need to just check the endpoints and compare them to the values that we get from taking the derivative. So hopefully that makes sense. Now let's go ahead and do the first step, which is checking when the derivative is 0. So let's do that. Well, g prime of t, that's equal to, let's see, 2 to the third, derivative of that is 6t squared using the power rule. 3t squared, derivative of that is just 6t. And then negative 12t minus 12, 4 goes away, and we set this equal to 0. Well, this right here looks like a polynomial that we can factor, right? So the first thing I'm going to do is I'm going to factor out a 6. So let's do this in a different color. Let's factor out a 6, and we get t squared plus a t minus 2. And now the inside, if this is equal to 0, then the inside can be 0, and the whole thing will be 0, right? So let's just work with the inside. Well, if we factor the inside, let's see, we're looking for two numbers that multiply to negative 2 and add up to 1. So in this case, 2 times negative 1 is negative 2, and then 2 minus 1 is 1. So that works, right? So our factor will be t, let's see, what were the numbers? Plus 2, right? And then times t minus 1. So again, we can multiply this out to make sure it works, but in this case it does. So let's see what t values we get. Well, if this portion of this expression is 0, then the whole thing is 0. And also if this portion is 0, then the whole thing is 0. So t could be negative 2, right, to make the whole thing 0, and t can be 1. So our two critical points that we need to check are 1 and negative 2, along with our endpoints. Now, let's make sure that these two values that we just determined are in the domain that they defined. So they defined the domain to be negative 4 to 2 inclusive. So let's see, is negative 2 in there? Yes, negative 2 is in between these two, and then 1 is also in between, so we are valid to check these 2 points. And make sure to do that because that's something that's usually commonly missed. So let's check t is equal to negative 2. Well, if we plug in t equals negative 2, what do we get for the function? So t equals negative 2, we get g of negative 2, which is equal to 2 times negative 2 to the third. Negative 2 to the third is negative 8 times 2, that's negative 16, plus 12, right? 3 times negative 2 squared, and then plus 24, and then plus 4. So let's figure out what this is. So it's negative 16 plus 4, that's negative 12 plus 12, those cancel, so this comes out to 24. All right, this might be the maximum. We're not sure yet, though. We have to check all the other points. Let's check G, or it might be the minimum, right? We're going to compare all of the points that we check at the end and see which one's the maximum, which was the minimum. So again, essentially what we're doing is we're saying these 2 points are a possibility to be a minimum and a maximum, and then these 2 points are a possibility to be a minimum and maximum. So now we're just checking and we'll compare them at the end. All right, let's check 1. So if we plug in 1, we get 2 plus 1 squared times 3, that's 3, minus 12 plus 4. This is 5 plus 4, that's 9, and 9 minus 12, that's negative 3. So this might be a minimum. Let's check the rest. Now we got to check t is equal to negative 4. Again, that's the endpoints, right? We're checking t equals negative 4. So let's plug that in. G of negative 4 is equal to negative 4 to the third. Let's see, what is that? Negative 4 times negative 4 is 16 times negative 4. It's negative 64 times 2, negative 128. Negative 128 plus 16 times 3. I believe that's 48. Yeah, 48. Minus 36 plus 4. All right, let's see what this is. Okay, so first let's figure out 48 minus 36. That's 12. 12 plus 4 is 16. So 16. So negative 128 plus 16. I believe that's negative 112. So it looks like this is definitely going to be the minimum. Let's check our last point. T is equal to 2. We plug in G of 2. We get 2 to the third, again, is 8 times 2 is 16 plus 12 minus 24 plus 4. All right, let's see, what can we cancel here? We get 20, 16 plus 4 is 20, 20 minus 24 is negative 4, and then 12 minus 4 is 8. So it doesn't look like this is anything. All right, so let's compare. We have 24, negative 3, negative 112, and 8. Well, it looks like this will be our minimum. So negative 112, this is our minimum, which occurs at t equals negative 4. And it looks like g of negative 2 will be our maximum, which occurs at negative 2 and is 24. So we found our maximum and we found our minimum using derivatives. Talk to you guys in the next video.